This conference will now be recorded.
So screen is visible, right?
Visible.
Yeah, fine. So that is the differences. So what are the differences we have seen? Connection oriented, connectionless. Okay, and it means connection. Why we call it as a connectionless connection? Because it follows the handshake and it doesn't follow handshake. Okay, and it is a reliable, but it is not a reliable. And TCP is slower but efficient, but UDP is not a slower. UDP is faster but not efficient, means no guarantee of packets. Okay, and here the retransmission is possible if the packet has been lost, because every packet will be acknowledged to the sender, but there is no any acknowledging mechanism in the UDP. Okay, so those are the major differences. So when it comes to where and all the TCP will be using, so HTTP, HTTPS, and all these cases will be using, you will be using the TCP, and UDP will be mostly will be using for video conferences is one best example. Apart from that, we'll be using DNS and SNMP. So we will discuss that once we go to those protocols. We will discuss about that, which protocols they are using. Okay, so that's a major differences between TCP and UDP. So let me. So we have studied about this OSI layer, OSI layer. So computer, what is the computer networking, LAN, MAN, WAN? Okay, and so the OSI layers we have studied about all the 7 layers. So, and this is the TCP header. So see here, what you are seeing is the TCP header. This is how the header will be looks. So in the transportation layer, so in the transportation layer, okay, we are adding this TCP header to the data. Okay, so what information it contains? So the port number and the destination, source port number and destination port number. Okay, source port is something, your mission port number. So that will be a randomly generated when you're trying to communicate to another mission. The source port is always a random number, and the destination port is what service you're trying to access. So for example, as earlier we have discussed, so we have discussed that, so if you are accessing the website, a secure website, or you're accessing some other resources, for example the banking site, so what is the destination port? What is the port number for that is the website sites? So websites in the sense HTTP or HTTPS we are using. Okay, so what is the port number should be in that case? So we have discussed yesterday. So as I said,
so
for HTTP 80, HTTPS 443.
correct. So HTTPS or SSL port number is 443. So then those the TCP header will be, the destination port will be 443, and the source port number will be something randomly generated, right? So sequence number, acknowledgement number. So sequence number is something when you start creating a handshake mechanism. So there will be every packet will be exchanging between you and the destination have the sequence number. So every packet have the sequence number. Okay, and the acknowledgement the same way, the acknowledgement number also have. So for example, so here I'm here. So as we discussed, this is a client and client mission, and this is the server. So the TCP three-way handshake, first it sends a synchronization packet. So every synchronization packet have the sequence number. For example, this is the sequence number is 100. It started, and then it sends a SYNAC. Okay, so that is also have a sequence number 100 plus 1. That is a like that. So that means 101. And then it also sends another. So it is also send its own sync in the same packet now. So again there will be a ACK, and the ACK have a, another 101 plus 1. So then 102. So like that. So it's I'm just taking an example, but it will be the random number again. So source port is always a random number. Okay, and the destination port will be what service you are trying to access, the website, which website you are trying to access. That is a 443. So now we are not using anyway HTTP, so we don't consider, but just remember HTTP or HTTPS means these are the port numbers. So you don't see anywhere inside that HTTP or HTTP. Yes, based on the port number only. So based on this port number only, the server can identify what type of access, what type of the service you are expecting from the Google. For example, if it is a something 25 to the Google web browser, it won't accept. Okay, so based on the port number only, it will identify the service. Okay, so remaining things also we have discussed. What can you see? So what you can see here, can you see here SYN synchronization packet, right? The sync packet. Okay, and then acknowledgement packet. Okay, and finish packet.
Finished.
FIN, yeah, FIN stands for a fin, SYN stands for a synchronization. Okay, and so these three majorly.
Reset,
And we,
RST.
ACK acknowledgement.
Yeah, so we have discussed the RST as well. So RST is reset. It's a forceful termination. Okay, so how does it looks? So for example, if I am sending you some data, okay, if I am initiating a synchronization packet, okay, so now the packet looks like this. Source port is something random, destination port is something 80 or 443, and now you have the sequence number, the something 100, and what else? Acknowledgement number should be 0, those cases, because this is the first packet. And then now you can see a lot of packets are there. It's a lot of flags. This we can call it as a flags. Okay, what are the flags are there? Sync, ACK, PIN, RST. Yeah, so these are the packets. Now when you are sending synchronization packet, the first packet, this will be 1. It becomes a active, means it becomes a 1. Remaining all flags are become a 0. Okay, so one, so in digital, we can see in digital electronics or in a binary digital communication and all. So the communication happens on zeros and ones. If 1 means high, means it is active, 0 means no active, no value for that. So 1, so one represents, so here the sync bit is, the synchronization packet is active, and the destination server will identify the based on the synchronization packet. If the client receives with a acknowledgement, okay, then client will, so the server will reply to the client, okay, with the SYNAC, that is this one. Okay, then now which bit will be activated? which flag will be activated? You got it, my point. So when you're sending a synchronization packet, SYN is a, so am I audible?
Yes.
Yeah.
Yes.
Yeah, so when I'm sending a packet to the destination, SYN flag will be active, right? I'm sending a synchronization. So remaining all bits are all remaining are 0. Now I'm getting a reply from the server, that is an acknowledgement. Now the acknowledgement will be become a 1 and remaining all are 0. And also the server also sending its own synchronization packet. So that's why these two flags become a 1, remaining all are 0. Right. Now if I want to terminate, if I want to close the session, I have done the downloading or browsing activity. Now you have how many flags? Sync, ACK, FIN, RST, push. Now which flag will be going to active?
Finish.
Which flag become? Yeah.
Finish, bro.
Yeah. So finish packet will be inactive, remaining all are 0. Okay. And this packet will be sent to the server. So the server will identify based on this packet. That's yes, this finish request you are sending, means you are sending. How does the server identify? So you are not telling, hey server, I'm sending a finish packet, please close. So you're not telling, right? You're not telling. How does the server identifies that this is the finished packet? So
based on acknowledge.
Yeah, so based on the packet received by the server. The server received a packet and the server received the packet. The packet contains the TCP header with the finished flag is set to be a 1 and remaining is 0. So that the server can, now the server understand that this packet is the finished packet. So I wanted to finish the session. So that's how these flags will work. Okay, so we don't need this. So data offset is something. So if every packet will be there will be offset value, which is not required for you. In terms of the communication, you don't need. But just data offset is something. So every packet value will be there. So for example, every packet length there will be a 0 to 32 bits, or you're dividing the whole information into packets, right? So which packet is contain what length of information, how much length? For example, if I send hi, hello, how are you? So, or how are you, I sent, and the how are you has been divided into 5 packets. So that how are you is a 10 KB of data, 10 KB of data, and that 10 KB of data has been divided into 5 packets, and each packet is a 2 KB. So that tells which packet starts from where. The first packet is 0 to 2000 bytes. After 2000 to second packet start from 2000 to 4000. So like that, the data offset will. So these things you have to, you don't need to much worry about it. So you have to know these things are very important. Again, the window is something. So that is another concept. So where how many packets you have to send one time. Okay. So for so now we are discussing. So every packet, each acknowledgement. Okay, every packet when you are sending to the destination, so you will be expecting a acknowledgement from the other end. So, but what the windowing is telling, so you have to mention how many packets. If let's say every packet I don't want, acknowledgement, I can say 5 packets, 1 acknowledgement, 5 packets or 1 acknowledgement. So that will be decided by the windowing. So these things you don't need in terms of the communication or in the networking part. This will be helpful, but okay, these things are important fields you have to understand. So because when you're analyzing the logs, and the log contains the ACK packet or a FIN packet. So then you have to understand what is the ACK or what is the FIN or what is the RST. So you have to understand that. So then only you can be able to understand, oh yeah, so if some attacker was trying to connect you and the firewall is doing RST, okay, RST, it was creating a log of RST. That means the firewall is stopping the traffic. Okay, so that's how those are the major flags. So SYN, SYNAC, FIN, reset, acknowledgement. Urgent is something, for example, it's like an ambulance. So when you are traveling, in the traffic, okay, some certain things are emergency, like a 108. Those things are very emergency. So what we are doing, so we are giving a way to those. So we are just going side and we are giving a way to those ambulances because those are emergencies. The same way, couple of data packets are coming with an emergency. It flagged as an emergency. So those will be allowed immediately. Means, so for example, if I send a 10 packets to the receiver, then 11th packet is a emergency packet. So that packet will be forwarded, means will be given to the receiver before the first 10 packages, because this is it will be considered as urgent. So all the 10 packets will be sided, and then this emergency set flag will be given to the onto the top. Okay. So for example, you're sending an email. So with sometimes you're sending an email with the urgent. Okay, so those will be flagged as a urgent. So those kind of things will be marked as a high priority and will be pushed to the receiver very quickly. Okay, that's how the flags will be there. The next will be in the networking layer. So we have seen that. Okay, so what happened in the transport layer? Whole data has been divided into your segments, and you will be adding in the TCP header. In the network layer, what you're doing, you'll be adding the IP header. So you're seeing here the IP header. IP header is what you have to know is, will tell you the versions. We have two versions are there in the IPs. So IPv4 or IPv6 will tell this class itself the versions of IP addresses. Okay, this is the length of the packet. So what is the length of the packet? It is the 31 bits, 31 bytes or something like that. 31 bits, or how does we can represent. So what type of service we are accessing. Okay, so what are the major things you have to focus here? Okay, source IP address and destination IP address you have to know. Other than, you don't need to much bother about any other things. So which is not helping us in terms of security. So you have to, whenever the packet is coming, what is the source IP address and what is the destination IP address, you have to focus. So here TTL also you can focus. TTL is something time to leave, but which is not required for us. So what major fields you have to look at? The source IP address and destination IP address. Source IP address is something your mission. So when for example, I am sending a packet to you, so it's like a postal. So when you are sending some courier to your friend, so you must write your source, your from address, and then you are also writing a to address. So the to address contains your destination address. The same way here, the source IP address contains your own mission details and destination IP address. Why we are mentioning the source address? Why we are mentioning a from address in the postal? Because in case it was failed to deliver, so you will get a packet reverse back, or you'll get an acknowledgement saying that this courier has been failed. The same way here also, if you are trying to deliver the packet and it was failed, so it must be delivered to you that it was failed. Okay, so that's a source IP address and destination IP address. So time to leave concept is using when the packet is reaching every hop. So that is a different concept. So for example, if I'm sending a packet to the Google server, there will be a TTL value should be a 32. So if the value, so I don't want to tell this again, so it will be confusion. So I don't want to create a confusion here. So you must understand these fields: source IP address and destination IP address. So if somebody is curious to understand what is the TTL, yeah, so you can ask me. So we'll clarify it. So if really you guys are required, so I'll clarify it. Okay. So this is a UDP and this is the header, UDP header. So UDP header, so it doesn't have any synchronization package or flags or nothing. Source port, destination port, length, and checksum. So checksum is again for the security reasons we have. What are the applications will be UDP will be using? So these are the normally it will be using for the real-time applications which cannot tolerate any uneven delays between sections of a receive. So there is no delay. So like video conferences there should not be a delay. So that's why we'll be using these things. Okay. And other than NTP, so these are the protocols, are there different protocols we will discuss about this, and DNS we will discuss, DHCP we will discuss, and so these are the routing protocols. Okay, so in the routing protocols also the DNS will be using. Okay, we'll discuss all this. We don't discuss this. Okay, this is a routing things we don't need. We need NTP, DNS, all the DHCP servers. We will discuss about this, and the application layer can do some of the tasks through UDP. The trace route we will discuss. Okay, and shit. So why we can use, why we are using for UDP, reduce the requirement of computer resources. Got it? So it's like there is no acknowledgement, there is no retransmission, so that there is no burden for your computer, right? So for example, if I'm initiating a traffic to, connecting to the Google, so I don't need to initiate a handshake, and then I don't need to send acknowledgement, I don't need to send a what is the sequence numbers, I don't need to bother about anything. So means the computer have a less work, so it doesn't occupy much resources. Okay, and when using the multicast or broadcast to transfer, so it doesn't, so it's not a unicast again. So there will be 3 letters are there: unicast, multicast, broadcast. Okay, so unicast is something, so you have to understand this as well. So what is the unicast, multicast, broadcast? So the unicast is something one-to-one. First, for example, take this broadcast. So broadcast is something you're going to. So for example, there is a set of people in the classroom. There is a set of people in the classroom, and so the one of the guy name was something XYZ. Okay. For example, we don't need to take XYZ. We take it as a Prasad. So, and one of the outside guy, so he wanted to pass, or Prasad got some courier from outside, and so the courier boy came, and so he came to, for example, this is a hostel. He came to hostel, and he is asking everybody. He is asking everybody, said, who is Prasad, because he don't know who is Prasad. So that's why he's asking everyone. So there is a set of people, 50 people are sitting in the hostel, and this guy came and he is asking in one shot, hey, who is a Prasad? And all the 50 out of 50 members, only Prasad will be responded to. Only Prasad will be responded to his query, right? So remaining all 49 members will be quiet. So this is called as broadcasting. So he is asking means everybody is asking. That is a broadcasting. Okay. So now only Prasad will be replying to this guy. Okay. Yes, I am the person. So, and this guy knows who is a Prasad now, right? This guy knows who is a Prasad, and he will transfer whatever he will give the courier to him. So broadcast is something asking everyone, asking the information in a computer terminology. If any of the computer doesn't know, if any of the computer doesn't know the destination address of another computer, it just broadcasts who is this IP address. Okay, so every computer receives within the network. Every computer receives this, and only the particular particular IP address related to this IP, which one is matched with that IP. So that will only respond. So once it is responded to the source mission, okay, then it will be the unicast, like Prasad and the courier guy. So once he knows the Prasad, so then they will start communicating. That is called as a unicast. Okay, so broadcast is something telling to everyone, asking everyone, and unicast is something getting a response from one guy and started communicating. So it is a unicast means between a two persons communication. Broadcast is everywhere, and multicast is something set of people. Okay, there is a group. For example, in your branches, so you got some information like so you have for example, you are a computer science CSC, and you have a section, B section, and XC section. Two sections are there as an example. Got it? So here, the one of a person want to deliver a session to CSC A department, CSC A batch. So that guy will come and will ask, will go and will deliver the session to this batch. Okay, it's a group. So communication between a it's a communication is happening between a groups. Okay, so multicast is something. There will be every multicast address will be something. For example, for a routing protocols like a BGP, OSP, of all these things they have their unique multicast address. So that's a multicast group. So every group they have a certain multicast address range. Okay, so that is what the differences. That is what the difference. Unicast, multicast, broadcast. Unicast is a one-to-one communication. Multicast is something group of people. Broadcast is something all the computers. The request will go to all the computers. Okay. So any question here? Okay, so that is applications. Okay, let me start with IP address and MAC address. So what is IP address? What do you know about IP address? What do you know about IP address?
It is actually it is a internet protocol to communicate with the system. To connect to a computer, or it is a internet protocol address to communicate with the computer.
Okay. So IP address is something. So you have a lot of computers are there. So for example, so there is an internet. There in an internet you have a lot of stuff like Google, Facebook, or whatever things. So and you have your computer. So if you want to communicate any of internet devices, or if you want to communicate any other devices over the network, if you want to communicate any of the device over the internet, you must need one identity to your device. You must need an identity. So you must need an identity of computer. So if you don't know, if you're not, so for example, if you're going to somewhere, okay, like as an example, you're going to some other company, and you so you should have or else you're attending one of a what we can say, IP address is something, it's we can tell in another way. Yeah, it's like, so for example, you're going to one of the company, and or you're going to any other college. For example, you're a student of one college and you're going for another college for the conference. And so how do you identify, how do you identify, or how do you introduce yourself to other people? So you must have a own identity, right? Otherwise they won't allow for to give us a seminar or whatever the things. So you must have a um, you must say that you are coming from this college and I am going to present this session, so that everybody will the college people will accept your seminar. College people will take that and accept the seminar, and they will allow you to give the presentation. So if you are coming from somewhere in the college or somewhere from the medical college and you wanted to present some medical things over the engineering college, in an engineering college, so that will be not be possible. So they don't allow because it doesn't useful. So it's an identity. So the same way here, every computer must have an identity. So every computer, so in order to go and access the resources over the network, you must need a one address. Okay, that is the internet protocol. Internet protocol address. So in order to route the traffic between two different devices, or in order to connect any other devices over the internet, or in a normal computer networking itself. So you must have a, so everybody, even for me itself, for me as well. So how does the people can identify me? So with my name, yes, with my name, everybody can identify, and everybody will communicate for somebody with my name. So you guys will be communicating. How you guys are communicating? You will be communicating. Yes, this guy was Narendra, and he's a cybersecurity trainer. So he will be giving a training, and his name is Narendra. So that is an identity. So everybody have the identity. So here also the same way, every computer have the identity. So in order to communicate over the network, you must assign a IP. That every computer must assign the IP address. Okay, now also I'm communicating to you. I'm communicating to you via the GoToMeeting, and I have a one, and my system have a one IP address, one IP address which is assigned by my internet service provider, right? So I'm connecting to the internet and I'm trying to communicate you. I'm communicating to you over the internet. My Wi-Fi, sir, my Wi-Fi, I purchased a one Wi-Fi, and that Wi-Fi assign an IP address to me. So and then only I'll be able to communicate you. If I don't have a IP address, if I don't have IP address means I don't have internet connection. So if I have the internet connection only, I'll get the IP address. I'll get the public IP address. So with that only I can able to means I am purchasing one IP address. So that is a, I am purchasing one IP address from my ISP, internet service provider, that is ACT or Geo or whatever it is. So that's how I will be communicating to you over the internet. Yes, right. I'm coming. I'm without an IP address. Should I able to communicate you now? No, I cannot. So what I'm doing, I purchased the IP address and I'm communicating to you. That is the IP address. So that is a, we can call it as a public IP address as well. So I'm purchasing one public IP which is provided by ASP, and that public IP will be assigned to my computer, and then I'll be communicating to you over the network. So in a simple word, IP is a, internet protocol is a is a unique address will be a address. We cannot call it as a unique. We can call it as an address which is assigned to every computer in order to communicate over the internet. So even the destination you're communicating to the Google server. The Google server must know, must understand, must reply to you when you have the IP address. So, and even if you don't have an IP address, you should not communicate to Google server. So that's how that is the IP address. Okay, got it. And there will be another one is called as a MAC address, media access control. So what is the MAC address? MAC address is the physical address of the device. This is a computer. So this is a computer, and every computer have a unique physical address. Unique physical address means, so this address, for example, this is XYZ is a MAC address, and this XYZ will be assigned to this computer only. Okay, no other computer in the world have this number, have this MAC address. So my computer have my own MAC address, and even if you are using a mobile, your mobile also have the own unique MAC address. It is not your MAC address should not have any other system, right? So like in your mobile we can say it's IME number. So IME number is a unique for every mobile number. It is not a same for, or whatever the number you have which is not given to any other person. It was unique for every person. The same, the MAC address is unique for everybody. It is the physical address of the device. So where exactly you have been located, your computer has been located in the network will be identified based on the MAC address. Okay, IP address is something when you connect. If I'm not connecting my computer is a standalone. My computer is not connected to the internet. It's just a simple normal your personal laptop, right? You just take your personal laptop and you're not connected to the internet, and it doesn't have any IP address. It just contains a MAC address. Once you connected to the internet or connected to any of a network, so then only you will get a IP address. So why we need a IP address, we have discussed. So in order to communicate any other devices, you must have a IP address. Okay, so otherwise there is no need of IP address. So but what is a MAC address? MAC address is a physical address which was given to every computer when they are manufacturing itself. Okay, but IP address is always different for every time. So now I connected ACT Wi-Fi router, and now my IP address is something. Now my IP address is something different. Okay, my IP address is one, and after that I have connected to the internet. Sorry, Geo internet. So then my IP address will be changes. So IP address will be changes every time for a computer, but MAC address will not change. And IP address will be used for to communicate internet resources. Okay, and the MAC address will be identified where exactly you have been located in the network. The network itself, inside where exactly you are there. Okay, this is something like, okay, you have been received a courier from. You have received a courier. In the courier, okay, in the courier, so they have written your name. Okay, for example, your father sent in some money order to you as an example. So right now we are not sending any money orders, but just take an example. So what is the to address? To address is something. To address is something what? Say Bharat. So Bharat is a one. So name first will contains a name Bharat, and Bharat belongs to the college or CSC department. Okay, CSC, and the college is something. Okay, SV University, CSC B section, and Tirupati, Andhra Pradesh. Okay, now see here, how does the courier will go? The first you're sending from somewhere in Telangana. So first they will identify this Andhra Pradesh and then Tirupati, and once it is go to the Tirupati, the first time means first they will identify this is belongs to Tirupati. So then it will identify this where exactly in the Tirupati SV University. In the SV University, where is this guy is located? CSE B section. Okay, and the postal guy will go to the from Tirupati to will go to the SV University, and the SV University will go to the CSE B section. So then he will ask who is Bharat. So then they will be identified. Okay, so here the IP address will be only here. So your physical address is the device physical address is the name of the candidate, and this is something. So CSE B section is not your permanent. So you may be the third year, you may be moved to the CSE C section, or after 4 years you may be moved from the SV University. So this is not the permanent, but your name is permanent. Okay, so the same way here. So these things, the IP address should always changes. So like your branch, so after 4 years your branch will be changed, or after and the same time your company, sorry, your college names will change, but only the Bharat will be the constant. The same way here, the computer MAC address is always same, but whenever you connect to a different service providers, so then those cases the IP address will always changes. So IP address will always change when you connect to different service providers, and it will not be same. For example, today I have connected to you guys with some IP address. So tomorrow I'll come and I'll connect with you guys with the same service provider, but that will not be the same IP address. So once you are using, so the same IP address will be there, then you stop using the IP for some time, so that IP address will be deallocated to you. It will not it will be freezed, or it will not be it will be assigned to somebody else, or it will be free. That IP free because you are not using, that IP will be free and will be assigned to some other person. So when you connect again, so there will be new IP will be assigned to you. Okay, but MAC is a constant for your computer. Let me So you can see here the IP address. What you are seeing is a IP address. Okay, so this is the IP address. Maybe tomorrow is something else. Sorry, this is a private. This one is always constant. But when you see where you can see here, we can see. So I want to see what is my IP address. I want to see my IP. What is my address? What is my So this is my IP address. So this is a public IP. Okay. So who is using this public IP? So I can see that where this IP belongs to. I'll get it what is the location of the IP address and the service provider and everything. I will get it here. What is this location? The location is, let me see here. What is the location? Atria coverage technologies. What do you mean the Atria technology coverages? This is a ACT, Act Private Act Service Provider. Okay, and you can see here the location. Also, you can see here the location where it is belongs to Bangalore. So I'm using the service provider. I'm in Bangalore, so that's why it shows a Bangalore. And the location I can also, who is the ISP also I can see. So just keep it in the mind. So I'm just saving it in just saving the IP address here. Okay, I'm just saving the IP address here. So just remember today this is the IP address, right? Today. Let's see tomorrow what is IP address. So some other else will be given to me, because so if I close the session and I stop using this IP, and after some time if I reconnect, it will not be the same IP address. Let's see tomorrow what IP address I'm gonna see. It will not be the same address. Okay, so that is a IP address. But when you see the MAC address, so MAC address is something. What you are seeing here is, so you can see here the physical address. So MAC address is a physical address. So, and this is a, see, you can see here the physical address. This is the constant for every device. So the same number will not be given to any of the people. The first three numbers is unique for any, like if it is an Intel manufacturer, so this will be the same. So you can identify based on this. This is an Intel or any other vendor, AMD processor, or who is a manufacturer. So this will be different. This will be different. This number will be different for, means maybe any of these will be changes. It will not be the same as the same. You cannot find in anywhere in the world for any of the computer. Okay, 1 second. So any questions here? So IP address and MAC address. So got it the difference when what is IP address and MAC address. Okay. So IP address have a, so any questions here, IP address versus MAC address? When we are
No, it's
using,
clear.
yeah, so when and where we are using IP and MAC address. So IP address are two types, version 4 and version 6 IP addresses. So we don't talk about V6 because we are not using V6 IP addresses. So we are using, so every computer have the V4 version of IP address. We are not using Currently, we are not using the IPv6. So IPv4 is a version 4 itself is telling one IP address can be represented in a 4 octets. Okay, one IP address represented in So so we have these are the classes. We have IPv4 and IPv6. So we will be representing why we call it as a version 4, because the IP address have a IP address v4 means we will be representing the IP address in a 4 octets. 4 octets. IPv6 will be representing one IP address is equal to one IP address will be 6 octets. 6 octets. Okay. So that's how the IP address. What do you mean? What is the octet? What is a one? What is a one octet? What is the value of one octet? So did you study the engineering? Did you when you studied digital electronics? So you must know what is a octet. Okay. So what is the octet?
Sorry, can I spell octets or octets?
Octet. Octet. Octet.
Octet.
So binary, we have in a binary, we have like in a digital electronics, you see there is a binary, decimal numbers, octets. So like that we have. Okay. So octet is something. So it's a 8 bits. One octet is equal to 8 bits. Okay. So we are representing one IP address in a 4 octets. Means 4 octet means, so take this is a 1 octet and this is a dot and this is a 1 octet, 1 octet and 1 octet. So means 1 octet contains 8 bits. 8 bits means bits. How we can represent a bits? 0 or 1. We will be representing the IP at binary numbers. So 0 or 1. So how do you represent one octet is equal to, in a binary, if you convert this octet into a binary, so it will be a 8 bits. Okay. So I am representing here, this is a 4 and this is a 4. Okay. This is a binary number. Okay. And this is the first value of any of the octet. What is the next value? 0 0 0 0 0 0 0 0 1 4. So like this, so not this one. And the next value is 0 0 0 0 0 0. This one is 1 and this one value become a 0, like that. Okay. Any IP address you are representing in a 4 octets, and each octet will be a 8-bit representation. 8-bit representation. So in a bit format, you'll be writing as like this: 8 bits dot 8 bits dot 8 bits dot. Let me write here another way. So IPv4, 4 octets, representing in a 4 octets. Each octet will be, what is each octet value? Each octet will be 8 bits. Let me write all the 4 octets. So 8 bits, right? Each octet will be 8 bits, right? Okay. 0 0 0 0 0 0. This is starting value dot. This is the 1 byte, 1 octet, and 0 0 0 0 0 0 8. These are the 8, and this is another octet dot 0 0 0 0 0 0. This is another octet 0 0 0. So like this, you will be. This is the binary value. Okay, this is a binary value, and if you convert this binary value into a decimal value, then this value will be a 0, and this value will be a 0, and this value will be a 0, and this value will be, the 4 octets will be represent it in a decimal format, this is how the IP looks. Okay, so now how many combinations we have? 2 power 8, right? We have how many zeros? 2 power 8 means we are representing one octet in a 8-bit representation, means 2 power 8. So did you following me, or we'll go the next session, because it was a little confused. So if you're
Sir,
okay, then we'll.
what is the difference between the bytes and octets? Bytes
See,
means it's
byte.
a 64
No,
64 bits equal to 1 byte.
no,
What is the difference between the octet
no, boss.
and byte?
So 1 byte is equal to 8 bits.
Yeah.
Got it?
Yeah.
So we're not talking about the bytes here. So we are talking about the octets. So 1 octet is equal to 8 bits
8 bits.
representation.
Okay.
8 bits. Okay. So now, so 8 bits, how do you are writing? So like this, we will be writing. Okay. So 8 bits means, so we can write how many combinations? So 2 power 8, right? So 2 power 8, how we can write? 2 power 8 combinations we have to write. 0 0, this is the one combination. Another combination 0 0 0 0 0 1 0 0 0 1 0. This is events you learn somewhere in the digital electronics, you got it. So like this you can write this many combinations. Okay, and 0 0 0 1 0 0 1000 0 0 1 0 0 0. So likewise the 1 will be coming in 2 words like this, from right side to left side. So every time when it is changing, so this value, when you represent this binary to normal value, it will be 0 decimal value, and this will be 1, and this will be 2, this will be 3. So like that. Okay, so anyway, so it will be a bit confused. I'll better start tomorrow, so it will be good. So we'll start with the tomorrow IP address, and so you just understand, you don't confuse about this, because this is, I know, just I'm explaining. But what you guys have to must understand, must remember is, you have to know the different classes of IP addresses. So I will tell you the ranges between the ranges of classes, and I'll tell you the public IP and private IP address, those classes. So that is okay, but that is what you have to remember. So these things and all will be an informative for you guys. So just memorize, just be aware of this. So so what is the 1 octet? What is the uh, uh, you know uh, how to, if you write a 4 octets in a decimal binary format, how does the IP address? So why we are not writing like, so normally address IP address will be like this, 192.168.0.10. But when you see, this is the decimal value. When you see this binary value, it will be something like this, 0 1 0 0 dot 1 0 0 0 0. It will everything will be written in 8 bits. Okay, so like this will be there, but you cannot understand, you cannot remember all these things. So that's why you're converting this binary number into a decimal number, so that you can easily remember the IP address. Right? So that's why you're converting the binary value of IP address to decimal for easy remembrance. Okay, so we'll discuss that tomorrow. We'll have another session. So we'll discuss about the IP address, and how does the IP address will be represented, classes of IP addresses, and all these things. So then we will start from tomorrow itself. Start from the different sort of protocols what we have. Okay, regular communications, what are the protocols we will be using, and we'll go with another 3 days with that. The complete week we will go with the protocols and their port numbers. And so you must have to, by Friday or Friday, I'll give you the complete list of protocols and their port numbers. You must at least remember 20 protocols and their port numbers. you have to remember. So that's very important. So that's a, and the same time, so once I have completed the networking section, I'll review everything, and I will give you what you have to remember. It doesn't mean you should not you should forget all the things, not like that. So the important things, so which majorly will be helping for you all the time in your future, all the time. So that I will tell you when I'm finishing off the networking concept. So probably we'll finish it off in Friday. So Friday or maybe Monday itself. So when I have completed the concept, I will review everything what we have covered and what should we have to remember, and everything all other you should have aware of everything, and make sure you have to keep it in your mind that what are the things you have to that helpful for you in the longer time, in a complete future and other future itself. It will be helpful for you. Okay. So yeah, that's all today's class. So if you have any questions, you can ask me, and or else, yeah, we'll close the session. I believe I think a few people left. It seems. Is that left? Hemant, Bharat.
So regarding
Fine.
its IPv4 and IPv6 differences.
Yeah, version differences. See, this IPv4 is supports 3 billion IP addresses. IPv6, see, IPv4 is already is going to be exhausted. So see, every device now, now whatever the IoT is coming, right? So IoT means every device is connected to the internet. So every device is connecting to the internet, even your washing machines, refrigerators, or whatever the electronic gadgets, and everything will be connected. So if you see, the human beings are the electronic devices are more than more than the human beings. So every device, even your CC cameras, your washing machine, your air conditioners, everything will be IoTs. Everything will be connected to the internet. So with the IPv4, we cannot, IPv4 supports this limit of IP address. So other than, so if you don't have IP addresses, you have to go another choice. That's IPv6. So IPv6 is more than, so it's a version. You can see that the two power it's a 6 octet representation. So means it will be always double the IP addresses of IPv4. So 3 billion of IP addresses means it supports more than 5 to 6 billions of IP addresses. So yeah, IPv4, IPv6 is using already in the American market, market, US and all will be using the IPv6. But yeah, I don't think so. I don't see anywhere in our side we are not using any IPv4. Yeah, in the career, maybe in the future, IPv6 also will be assigned to your computers itself. So right now, I don't see any of the systems have the IPv6.
Okay.
It's the next version. Like IPv4 is a earlier there will be a IPv2. I don't know. If the IPv4 is exhausted, means over. There is no way, there is no any free of IP addresses in the IP. Everything occupied. Then you have to go for IPv6. So other benefits also there. So that's the reason. So any questions other than this? Okay. Okay, fine. So we'll close the session today, and we'll meet you tomorrow. And I have received a couple of CVs, so I have done already the CV preparation, so I have to update into your Naukri. Okay, and I'll confirm you by the evening. It's today evening. I'll confirm it. I'll do it everything, and I'll confirm you guys, and make sure go to the Naukri portal, search, and tomorrow I will tell you so what to talk to the HRs and everything. I'll tell you. Okay, tomorrow I'll discuss about that. Okay.
Okay.
Okay, thank you.
Thank you.